In this video 2-3, we will be comparing and ordering rational numbers. By the end of the video and work time in class, you should be able to say, I can compare and order rational numbers. Some vocabulary here to start off with. LCM is the least common multiple. We will be using common multiples here shortly when comparing. And specifically, we'll look at LCDs, which are least common denominators. We will be comparing using LCD first. So we are going to start here. I'll show you, we'll take the rational number 4/9 and we will compare it to the rational number 5/12. And so what we're going to do is we're going to take the denominators. So we're going to take the denominators 9 and 12, and we're going to list out the common multiples of 9 and 12. So our common multiples of 9, we have 9, 18, 27, 36. We could keep going on. We're going to stop right there. Our multiples of 12, we have 12, 24, 36, and we see then that we have our common multiple of 36. So now what we're going to do is we're going to rewrite the problem so that their denominators are both 36, because we know that that's a common multiple of 9 and 12. Okay. Now if we change a denominator in a rational number, we have to change the numerator as well. We know that 9 times 4 gives us that 36, so we do the same to the numerator. 4 times 4 to give us 16. And we know 12 times 3 is 36, so we do the same to the numerator to get 15. So then we see we have 16 out of 36 and 15 out of 36. So when we have that common denominator, we have a common whole that we're working with. So if I was seeing if someone had 16 out of 36, let's say pieces of candy, and someone else had 15 out of 36, who had more? The person with the 16 out of 36. And we know our symbol, it opens up to the greater value, like our alligator eats the bigger number. And so it's going, the bigger side is open to that greater number. It's eating the greater number. So we read that 1636 is greater than 1536. So then that means 4/9 is, that is our greater than sign. The smartboard is not fixed here yet. 4/9 is greater than 5/12. So that's one way to compare using the LCD. Another way to compare is using decimals. So if I had the rational numbers 7/11 and let's see, how about 8/12? Now if we take those rational numbers and turn them into decimals, so 7 divided by 11, we get 0.63636363. It repeats. If we turn 8/12 into a decimal, 8 divided by 12, we get 0.6 repeating. So we either have 0.63636363 or we have 0.6666666. Well, when we're comparing decimals, if we have 6363 so on, and we have 0.66666 and so on, it goes on forever. If we look at place value, in the tenths they're the same, they both have a 6, but then when we look at our hundredths, we have a 3 here and we have a 6 here, so that means that 6 is greater, so 0.6 repeating is greater. So that means 7/11 is less than 8/12. Once again, our symbol, our inequality symbol, it's a less than symbol because the open side is facing the greater value. 8 out of 12 is greater than 7 out of 11. So this is using a decimal. we'll use another one, or I'll show you with another example here. If we had 37/58 and we were comparing it to a rational number 45/71, and we turn both of these into decimals, we would have 0.6379, and it goes on here for 37/58, and for 45/71 we have 0.6338. And in comparing the place values of the digits, we have a 6, a 3, and then it changes here, 7 and 3. So then the 7 is greater, so that means that 37/58 is greater than 45/71. Now, the other thing to keep in mind is if I all of a sudden said that these rational numbers are negative, then what we would do is we would take that sign and we would reverse the symbol. So this would be negative 37/58 is less than negative 45/71. Because think about this, the greater the negative, the bigger that negative is, the smaller it is. So if you have two negatives that you're comparing, you could ignore the negative sign, see which one is bigger, but then when you realize they're both negative, reverse the sign around. We're going to be ordering rational numbers as well. So we're going to have the following rational numbers to order. We have negative 0.175, 2/3, negative 5/8, 1.7, and negative 0.95. We're going to take a number line. I'm going to put 0 in the middle. Here's 1, 2, negative 1, negative 2. I am then going to break my intervals into halves, and then into quarters. What we are going to do is place the values on the number line. So we're going to start negative 0.175 is going to be just a little to the left. It's greater than negative 0.25, but it'd be right about here. That's negative 0.175. Then we're going with 2/3, and we know 2/3 is 0.6 repeating, so it's a little bit more than 0.5, less than 0.75. Then negative 5/8, so we can see what 5/8 is as a decimal. It's more than half, because half would be 4/8, so it's a little bit more than half. Now it's negative, so it's the left of 0. It's a little less than negative half. Remember, it's negative, so it's further away from 0. The bigger that negative gets, the further away. So it's to the left of negative 1/2. Then we have 1.7. So I know where 1.75 is exactly, so we have 1.7 right about here. And then negative 0.95, that's close to negative 1 whole. So we're going right over here with negative 0.95. So now that we located these rational numbers on a number line, they are now in order from least to greatest for us. We have negative 0.95 is the smallest value, negative 5/8, negative 0.175, and we have 2/3 and 1.7. Can you say, I can compare and order rational numbers? For your output, I want you to compare the following rational numbers with 4 colors. So I gave you the rational numbers here, 0.17, 1/5, negative 0.3, 0, and negative 1/4. First in one color, write out the problem. In another color, show your work. In a third color, write your answer. And then in a fourth color, explain how you compared the rational numbers. So that's explaining the methods you used.